Good morning to all of you. Today we'll talk about the Friedel Craft reaction. In Friedel Craft reaction, benzene is alkylated or acylated. Benzene is alkylated or acylated. Benzene in presence of alkyl halide, the fixed name is alkyl chloride. In presence of the aluminum chloride is the alkylated product. And other reaction that is called the acylation reaction. This reaction is called the Friedel Craft alkylation reaction. Friedel Craft alkylation reaction. And also when benzene reacts with acyl chloride, is acylated product. When benzene reacts with acyl chloride, in presence of the catalyst anhydrous aluminum chloride, it is acylated product. This reaction is called Friedel Craft acylation reaction. In this reaction, Friedel Craft alkylation reaction, electrophile is generated. Also, in Friedel Craft acylation reaction, electrophile is generated. Alkyl carbocation which acts as electrophile, and acyl carbocation is also act as electrophile. The general reaction of both these reactions comes under the category of electrophilic aromatic substitution reaction. When electrophile is generated, that electrophile may be methyl carbocation, 1 degree carbocation, 2 degree and 3 degree carbocation comes on the next page. So now the electrophile generated is methyl carbocation, 1 degree carbocation, 2 degree or 3 degree carbocation. Electrophile generated is maybe methyl carbocation, 1 degree, 2 degree and 3 degree carbocation. Methyl carbocation, In case of methyl carbocation, it will not rearrange anymore. So there is no rearrangement. 1 degree or 2 degree. If there is chance of rearrangement, it can rearrange. Can rearrange. This may be, in this case also there is no rearrangement. There is a no rearrangement. No rearrangement, no rearrange. This is some rearrangement. There is some examples. We are going to see how it's going to rearrange. CH2 plus no rearrangement. No rearrangement. CH3, CH2 plus 1 degree carbocation. This is a 1 degree carbocation. This hydride shift with the 2 degree carbocation. There is a shifting. This hydride shift, this is known as a 1-2 hydride shift. This is known as 1,2 hydride shift. Hydride shift and generated degree carbocation. In this way, we can also rearrange the active one into 3 degree, depending on the possibility the carbocation generated. It may be rearranged into 2 degree into 3 degree, depends on the situation and scenario. We can rearrange. Mechanism of Friedel Craft reaction. Now we will talk about the mechanism of Friedel Craft reaction, that is how the reaction is going to proceed. So in this step 1, there is a step 1. First, attacking reagent, alkyl halide. Alkyl chloride, you can say also, think like that, alkyl chloride is going to take it. Alkyl chloride in presence of Lewis acid, LCL3, and hydrosol, and interact to each other. The lone pair of this alkyl chloride reacts with LCL3, which acts as a Lewis. It acts as a what? Lewis acid. Lewis acid interact, and there is a cleavage of carbon Cl bond. There is a cleavage of carbon Cl bond and generate carbocation. This is a hydrolytic fission. Hydrolytic fission, that is a generation of anion, cation or anion, and finally proceed in this application. And this is basically what? This is a electrophile. Electron deficient species, which contains 6 electrons. For the step 2, this electrophile generated attack on the benzene, because benzene is the electron-rich species which can donate the pi electron. So now attack of electrophile on benzene. In this case, the electrophile generated attack on benzene. Electrophile generated attack on benzene. And this species is basically carbocation, and name is areninium ion. This is species what? Areninium ion. This areninium ion attack on the electrophile benzene. In this process, the pi electrons of benzene attack on the electrophile, and in this case there is a formation of carbon-carbon bond and loss of aromaticity. In this case, what? There is a loss of aromaticity. Loss of aromaticity. And this areninium ion is resonance stabilizer. This resonance stabilizer species this arrhenium ion is resonance stabilizer in which this carbocation generated is 2 degree is resonance stabilized and form also 2 degree. Further, this pi electron also resonate with this positive charge and give this arrhenium ion. The arrhenium ion, these steps can link that they are resonance stabilized format. All are called the resulting structure. These all are called the resonating structure. And in next step, there is a loss of S plus ion. Loss of S plus ion from the arrhenium ion. To loss of S plus ion with the help of LCl3, LCl4 minus which act as a base which help in removal of S plus ion, and this step is basically gain of aromaticity. Gain of aromaticity. Gain of aromaticity. This is first step. So all the all these are a mechanism how benzene ring is alkylated. First electrophile is generated, and that electrophile attack on the benzene and for arrhenium ion, and arrhenium ion get the resonance stabilized with the help of the delocalization of the pi electron through the ring cyclic format, and finally there is a loss of S plus ion which is helped by the LCl4 minus, and this final product is achieved. There is some limitation of the Friedel Craft reaction. What is the limitation? Just come on. So now we look at on the limitation of the Friedel Craft reaction. In which situation the reaction will not proceed, which alkyl halide will not going to fuse. So first of all, we talk about the aniline. Aniline will not Friedel Craft reaction. All these components cannot be used as attacking a reagent in Friedel Craft reaction. Aniline substrate cannot be used during the Friedel Craft reaction, and this attacking reagent cannot be used as a attacking attacking reagent cannot be used in Friedel Craft reaction. All these are a limitation of the Friedel Craft reaction. Now we talk about some question on the Friedel Craft reaction. Now, so benzene taken as substrate or any benzene derivative can also take. And methyl chloride as a attacking reagent. This is attacking reagent. And this is basically substrate. This is substrate, this is attacking reagent, this is a catalyst. This is our product. This is our product. And this hydrogen is removed and this Cl removed from the attacking reagent, and this finally as a side product. In the equation first, this attacking reagent and catalyst interact with each other and generate the electrophile CH3. So steps are that steps is CH3Cl plus LCl3 interact with each other. This is a methyl chloride, a chloromethane, can say, or this is a Lewis acid. This is what? Lewis acid. This is the Lewis acid. When this lone pair of the Cl interact with the LCl3, generate CH3 plus and LCl4 minus. And finally this electrophile. This electrophile attack on benzene ring. The state 2, there is an attack of this on benzene ring. This CH3 electrophile attack on a benzene ring and give electrophilic aromatic substitution reaction. Give electrophilic aromatic substitution reaction. This is a final product. How this first the attacking reagent and the Lewis acid interact to each other and produce electrophile. This electrophile is a methyl carbocation. This methyl carbocation will not rearrange anymore. That will finally attack on the benzene ring, and this attack on the benzene ring and form a reaction intermediate, that is what the areneamide, and final genoaromatically produced this toluene. The methyl benzene.